So welcome back, class. This is our last unit of work around circuits until we begin magnetism. So let's just focus on this. So what is power? Well, power is defined as the amount of energy transferred per unit time, and it has the units of the watt, which is capital W, i.e. it's the amount of energy transferred every second. And 1 watt is equal to 1 joule per second. And power is the current times the potential difference, or I times V. So power is current times potential difference, or voltage. So P equals I times V. And just to make sure we get the units right, power is in joules per second, which equals coulombs per second, which is current. Okay, so that's what current is, times joules per coulomb, which is, of course, voltage from our previous lessons. So the coulombs cancel out, giving joules per second. So if we know two of the three values in an equation, we can work out a third, which is pretty much what you'll do for level 2 in terms of power equations. So for mains electricity in New Zealand, the voltage is 240 volts. That's what the standard value is. And the power rating is often shown as 60 watt bulb or a 1.2 kilowatt kettle, for example. So we can therefore calculate the current flowing through any appliance because we have both the power and the voltage. So here's your challenge. Use the information provided on the appliances to calculate the unknown. So for example, if an appliance has a power rating, you know how many watts it uses, and a voltage rating, you can calculate the current. And you can record these calculations in your notes. So here's a table to complete in your own time. I've given you a series of appliances, an equation, given you also the power rating and the voltage. You need to know what the current is needed for the particular appliance, and also the fuse needed. Now the fuse basically blows when the current gets too large. So you need to have a fuse which is slightly larger than the current needed. That's for you to do in your own time. Okay, also with power, you can also incorporate other formula. So you can combine physics equations to create useful equations which we can apply in different contexts. And the two equations we're looking at are P equals IV, which was just learned today, or power equals current times voltage, and Ohm's law, voltage equals current times resistance. So we have P equals VI, not a problem, we've already got that today. So if you substitute voltage equals IR into the equation, okay, so you're going to be replacing voltage with IR, you'll end up with I squared times R, okay? So all you're doing is going I R times current, okay? So you get I squared divided by R. That's a useful equation, so you should remember that. Next equation you can do is you've got P equals VI again, okay? So if you this time substitute I equals V divided by R by rearranging this equation, you get power equaling V squared divided by R, okay? So what you've done is you've got V times V over R, so that's V squared divided by R. So that's another important equation that you can employ using the power of incorporating these two equations together. The result, P equals I squared R, illustrates an important feature of currents in circuits. When the current through a resistor doubles, the power dissipates or is transferred as heat energy increases by 2 squared, or 4 times. This often has disastrous results for the resistor, and you can end up burning the damn thing like toast, which I've had in my classes when you've kind of pumped too much voltage or current through. So in terms of the relationship between energy and power, if the power is the amount of energy transferred every second, the total energy will be power times time. Okay, E equals P times T. For example, if a 1200 watt kettle is used for 3 minutes, what is the total energy transferred? So pause the video now, think about that, and come back and see if you've got the answer right. Okay, so welcome back. So the answer is, of course, E equals P times T, 1200 watts, which is the power, times 180 seconds. Notice you're converting to seconds from minutes. Gives 216,000 joules, or 216 kilojoules. So here's some questions. What is the power rating of a light bulb that transfers 120 joules of energy in 2 seconds? Okay, so looking through this, we've got some numbers. We've got energy and time. Power equals energy divided by time, which will equal 120 divided by 2, which equals 60 watts. That's the answer for that one. Next question. What is the power of an electric fire, or well, I guess you could call it an electric heater, that transfers 10,000 joules of energy in 5 seconds? Again, power equals energy divided by time, which will equal 10,000 divided by 5, which equal 2,000 watts. This was pretty expected for an electric heater. And the final one is, how much energy does a 150 watt light bulb transfer in 1 second and 1 minute? Now be careful with that 1 minute. Okay, so for part A, it's going to be how much energy. So it's energy equals P times T, which will mean that it's going to be 150 times 1, which is 150 joules. Remember, it's joules now because we're dealing with energy. That's for part A. And for part B, again, energy equals P times T, which will equal 150 times 1 minute, 60, which equals 9,000 joules. Right, so that's the answers for that one. So moving along to energy and power again, since power equals current times potential difference or voltage, then energy equals power times time. Then energy, if you just simply insert power into the equation, equals current times potential difference times time. Or E equals current times voltage times time. Now I'm just going to go through that in my head so I get it right. So it's, oh yeah, that's okay. So what you're doing is you're pretty much just replacing power from the first equation into the energy equation. Okay. So for example, how much energy will be transferred to a 1.5 volt bulb if a current of 1 amp flowed for 10 seconds? So again, pause the video, write an answer down and see what you get, if it's the same as what I get. Okay, so the answer is E equals current times voltage times time. So let's plug in the numbers. 1 times 1.5 times 10 gives 15 joules. Not much, but you know, not bad. So here's the final set of questions before the lesson ends to make sure you've understood that concept. How much energy is transferred to a light bulb, which is 12 volts and a current of 2 amps for 30 seconds? So again, pause the video, see if you get an answer, and then come back and see if you're on the right track. Okay, so our equation equals energy equals current times voltage times time. So we just quickly plug in the numbers. We have a current of 2. We have a voltage of 12. That's not the best written. Of 12. And we have a time of 30 seconds, which will give an overall answer of 720 joules. Right. Next question. How much energy is transferred to a 24 volt bulb when a current of 4 amps flows for 40 seconds? Again, pause the video and come back in a few seconds. Okay, so again, the equation, as we've already discussed, is current times voltage times time. Let's plug in the numbers. So you've got a current here, so it's going to be 4 times 24 times 40, which equals a grand total of 3,840 joules. Easy peasy. And the final question, how much energy is transferred to a 12 volt bulb when a current of 2 amps flows for 2 minutes? Again, pause the video now and go through the answers in a few seconds or a few minutes. Okay, so just like in the previous questions, energy equals current times voltage times time, which current is going to be 2, the voltage is going to be 12, and the time is going to be 120. Now note, it's 2 times 60 seconds, okay, so it needs to be in seconds. So the answer is 2,820 joules. So hopefully you've learnt something today about the wonderful world of power and energy. And the next lesson, we're going to move into the wonderful, mysterious world of magnetism.